Now see, today we are going to start with Unit 3. We have got electrochemistry. Now when I talk about electrochemistry, what should come first to your mind? It is all about chemistry of electrons. Already in 11th standard we have studied about oxidation and reduction in redox chapter. Now here, when I talk about electrochemistry, the definition is study of generation of electricity from the energy released during spontaneous chemical reaction and use of the electrical energy to carry out chemical reaction which do not occur spontaneously. Now say for example, we have drastic use of disinfectant right now because of the prevailing situation that we are having right now all over our country or all over the world, I can say. We are using sodium hypochlorite as disinfectant. Now this same sodium hypochlorite that is over here, NaOCl, is actually produced using electrochemical reaction. Similarly, if you see nervous system, the impulses that travel in our nervous system is again because of electrochemical reaction. You have got oxidation, several oxidation and reduction reactions. For example, when you eat food, you perspire. There is perspiration. Now that is just because of the oxidation of food in our stomach. As soon as you eat food, the food goes down through your food pipe, goes into your stomach, and the oxidation reduction reaction starts. If you see in nature, there are several oxidation reduction reactions occurring because you cannot have just one oxidation reaction going, that is oxidation half reaction, or you can not have just one reduction reaction going on. Oxidation and reduction reaction actually occurs simultaneously. Okay, now here let us go further. When you talk about electrochemical cell, you got two types. You got the voltaic cell or the galvanic cell or the Daniell cell, and you have got the second type, that is electrolytic cell. In case of voltaic cell or galvanic cell, chemical energy is converted to electrical energy. In the case of electrolytic cell, it's just opposite. Electrical energy is converted into chemical energy. Now let us go with the figure of this diagram of this Daniell cell. Now there are two compartments, or you can say there are two vessels or two beakers. The first beaker, the beaker to the left hand side here, contains zinc electrode which is acting as anode. To the right we have cathode where copper is acting as cathode. The sign is negative for anode over here. The sign is positive here for cathode. Now if you see, when the reactions begins, the reaction can only begin when electrolytes are added into it. It is this electrolytes which produces the electron, and it is this electrolytes which facilitates oxidation and reduction reaction. Here this is your zinc electrode and this is your copper electrode. Now what happens? We have corresponding salt solution. You have zinc acting as anode. The corresponding salt solution of zinc, that is zinc nitrate, is added. It is aqueous solution. Similarly for copper, which is acting as cathode, corresponding salt solution, that is copper nitrate, is added into it. To maintain the electrical neutrality, we are having the construction of salt bridge. Now the main function of salt bridge I will discuss later. Now what happens? As soon as the reaction starts means the oxidation reaction of zinc, reduction reaction of copper starts. That means here in this half cell, zinc is getting oxidized. Zinc solid gives zinc plus 2 ion and 2 moles of electrons are also released. On the right hand side, copper 2 plus gains that 2 moles of electron which are released by zinc, and the copper gets reduced. So here, when zinc is releasing the electron, that is zinc solid giving Zn2 plus 2 mole of electron. Now this electron has to travel through the external circuit where voltmeter is also connected. The voltmeter actually shows, the deflection in the voltmeter will show that the current is flowing, because the electron, here you can see the electron is traveling in this direction, that is from zinc to copper. The electrons are traveling, so the current has to travel in the opposite direction. You have already learned in your lower classes that the current will always flow in the opposite direction of the flow of electrons. So when the electrons are traveling from anode to cathode, the current, the electric current will travel from right hand side, that is from this half cell containing copper electrode to this half cell which contains zinc electrode. Here, so voltmeter deflection will show actually the flow of the current from copper to zinc. Now, going ahead, when this reaction proceeds for some time, what will happen? You will have the production of zinc plus 2 ions here. So positive charge will be developed here. Zinc plus 2. Because it is giving zinc solid gives Zn plus 2 electron. And here you will have copper. Not copper. Let us see. The reaction is copper 2 plus gaining 2 moles of electron giving copper solid. So here the mass of copper electrode will increase, while here zinc is getting dissolved, zinc is getting oxidized, so the mass of zinc electrode will decrease. Again I repeat, the mass of zinc electrode here will decrease because it is getting oxidized, it is getting dissolved. While in this case, to the right hand side, in this particular half cell containing copper nitrate electrolyte, the copper is getting reduced. That is, copper plus 2 in this solution gains 2 moles of electron which is obtained through this external circuit, and copper is reduced. That means the mass of the copper has to increase. There is n number, millions of copper 2 plus ions getting reduced, and copper is deposited in solid state here in the solution. Okay, I cannot put it over here because above the solution the copper cannot fly in the air and get deposited on the electrode. Okay, and actually this all part has to, most part of this electrode has to be dipped. Okay, now going through this, what will happen when copper is getting reduced? You will have more number of NO3 minus ions here. So this will become negative. So a polarity is developed. Now to maintain electrical neutrality of the solution, you have KNO3, saturated potassium nitrate is used in this salt bridge. So here you will have NO3 minus ions traveling. NO3 minus ions will travel to the salt bridge and will come over here and diffuse the situation of polarization. Similarly, potassium ions will come to this side and it will try to diffuse the polarity that is developed because of nitrate ion. Negative charge will get diffused there. So this way the function of salt bridge is achieved here because it maintains electrical neutrality of the solution and hence the reaction goes smoothly. Now here, if I go with the reaction, that it is also known as a net reaction, that is, if you add these two reactions together, you get zinc solid plus copper 2 plus aqueous gives copper solid plus zinc 2 plus aqueous. If you go with the cell representation, normally in the cell representation, what we do is, the anode is always represented on the left hand side and the cathode is always represented on the right hand side. So here, anode, that is zinc solid, / a vertical line is put to show its active ion, that is zinc 2 plus aqueous, If the concentration is known, say for example 0.01 molar, 1 molar, 0.2 molar, whatever is there, that concentration has to be represented over here. Now you have got a double slash, that is a double vertical line, which indicates the presence of salt bridge. You have now copper 2 plus. This copper 2 plus aqueous gets reduced to give copper solid, hence it is to the right hand side. Clear? If suppose the concentration is known, you put the concentration of the copper 2 plus ions which is there. If we know that the concentration is 1 molar, I will use 1 molar over here. Okay? If there is change in the concentration, you can put accordingly whatever concentration is there. Now, when this cell starts working, there is electromotive force that is developed. There is a potential difference that is developed, and that is always calculated using E cell is equal to E right minus E left. That is the potential of the right half cell and the potential of the left half cell. The half cell is nothing but zinc plus its corresponding salt solution, that is zinc nitrate, and this half cell, when I talk about it, is copper plus copper nitrate aqueous solution, that is the corresponding salt solution. Now here, if this cell is in standard state, that is 298 K temperature, standard condition in case of students always get confused between the standard condition of gaseous state, that is states of matter and everything, which you studied in 11th standard, and electrochemistry. When you talk about thermochemistry and electrochemistry, my dear students, it is always 298 K, because reactions cannot occur below 0 degrees Celsius. Okay, if suppose these electrolytes are frozen, do you think the reactions can occur? No, reactions can never occur. It can occur only at optimum temperature, and that is 298 Kelvin temperature, that is 25 degrees Celsius, 1 molar concentration of electrolyte, then only it is known as standard state. Then EMF is written as E degree cell, that is E naught cell also it is known as. Okay, some say E degree cell, some say E naught cell, it is all your choice, you have all liberty. That is E naught cell is equal to E naught cathode minus E naught anode. So cathode means you have got the copper one, anode means you have got the zinc one. So if you go to, my dear students, this is the table there in your textbook. In the table 3.1, okay, you don't have to zoom it out, let it be as it is. Okay, you can see hydrogen is there in the center, okay, and arbitrarily it is given 0.0 volt. Hydrogen, we have studied standard hydrogen electrode also. The voltage is arbitrarily given as 0.0. We accepted it because hydrogen should actually come between group 1, okay, and this group 70, that is the halogen elements. Okay, we have already studied this thing in 11th standard in classification of elements and periodic properties, that normally hydrogen cannot be kept either in the group 1 or group 17 because it has got properties which are similar to that of alkali metals, that is group 1, and to that of halogen elements, that is group 70. Clear? Now those elements which are below, so hydrogen, standard hydrogen electrode becomes a reference for us. Something which goes below that always have got the tendency to get oxidized. You can see these are known as standard electrode potential at 298 K, standard condition, table 3.1 of your textbook. Now here if you see zinc, Zn plus 2 electron, zinc salt, it gives minus 0.76. So this is actually a reduction potential because there is gain of electron. Clear? And when you go to copper, that is copper 2 plus, don't go to copper plus and don't get confused and don't confuse yourself. Copper 2 plus 2 electron, copper solid gives 0.34 volt. Yeah, this is in your book. Table 3.1, I have got a very old textbook. Maybe a decade old, I think. Okay, you may have the latest version, but the things remains the same. It will not differ. The chemistry never changes. Okay, chemistry remains the same. Now here, if you come to this, as I said, cathode, that is copper, 0.34 volt, minus sign as it is, and you have got zinc. It is minus 0.76 volt, minus of minus will become plus. So it is 0.34 plus 0.76, that is 1.1 volt. Clear? So the standard cell potential for such type of cell that we have calculated using the formula is 1.1 volt. Let it be very clear. Now if external potential is applied, Now the whole scenario changes. If external potential is, that is E external, cell potential, external cell potential we are putting onto this. So if it is less than 1.1 volt, if it is greater than 1.1 volt, and if it is equal to 1.1 volt, what condition arises or what really happens here? So if external cell potential is less than 1.1 volt, electron flows from zinc to copper. That is what the ordinary condition is, zinc to copper. So current will flow from copper to zinc, that is here, this same condition. So in that scenario, zinc will get oxidized, copper will get reduced. That means zinc will dissolve and copper will get deposited, will solidify, in other way if you want to say. Okay. Now if the external cell potential is greater than 1.1 volt, then the opposite occurs. What will happen? The electron flow direction will change. What is happening here? The opposite will happen. Zinc will not get oxidized, instead zinc will get reduced. Copper will not get reduced, instead copper will get oxidized. Okay. So that is a case of an electrolytic cell, my dear students. Okay. That is the case of electrolytic cell. पूरा ऊंधा हो जाएगा. Okay. So in electrolytic cell, the anode will be, that is this will be positive and cathode will be negative. Okay. Always remember, in an electrochemical cell like this, okay, that is Danieli cell like this, where anode is negative, cathode is positive, but in case of electrolytic cell, the whole thing changes. We will discuss it in detail later on. What about if the external voltage, external cell potential is equal to 1.1 volt? There is no flow of current, no chemical reaction will occur. Okay. Now let us go to the definition of the cell potential. Potential difference between the two electrodes of a galvanic cell is called cell potential. Potential difference between the two electrodes of a galvanic cell. These are the two electrodes. They are actually two cells. Two electrodes are dipped in their corresponding salt solution. So difference between the potential difference between the two electrodes is known as the cell potential. Now let us come to standard hydrogen electrode. Now standard word itself implies that the temperature has to be 298 Kelvin and 1 molar concentration has to be there. Now here if you see in the beaker, you got a hollow glass tube, your inlet for hydrogen gas. It has to be a pure hydrogen gas. The gas is at 1 bar, that is 1 atmosphere. You have got a platinum electrode, or okay, I can see the wire. It is connected to the plate which is coated with platinum black. This platinum black is coated so that the surface area increases and you can have the maximum amount of reaction. Okay, more is the surface area, more is the rate of reaction. Now here, there are two reactions that can be expected. H plus aqueous 1 molar, gaining 1 mole of electron to give half H2 gas. This is known as reduction half reaction because there is gain of electron. If it acts as anode, so you will have oxidation half reaction where half H2 gas means the whole reaction gets reversed, H plus 1 molar plus 1 mole of electron. Now here, if you see my dear students, this whole solution is 1 molar H plus, okay, or I say 1 molar HCl, it will naturally give or it will produce 1 molar H plus. You got a platinum, you got a wire for the connection. Now this particular thing will act as a half cell. It will be a standard to calculate the potential of another half cell whose cell potential is not known to us, whose half cell potential is not known to us. How? Here, naturally platinum is there, which is the inert electrode, which is used here in the standard hydrogen electrode. You have got platinum slash H2 gas 1 bar, H plus aqueous 1 bar, double slash, that is for the salt bridge, Cu2 plus aqueous 1 molar, Cu solid. So if this half cell, that is this standard hydrogen electrode, is connected with a standard half cell of copper. Standard half cell of copper, that means 1 molar concentration of copper nitrate should be there. And temperature will be naturally 298. In that scenario, you will have this type of cell representation. There, the standard hydrogen electrode will act as anode. Clear? I have shown you the table 3.1. Similarly, zinc solid, Zn2 plus 1 molar, double slash, H plus. Now here you can see the standard hydrogen electrode is acting as cathode. Here it is acting as anode, here it is acting as cathode. And when this is there, if you have to calculate the cell potential, standard cell potential, yes, you can calculate E degree cell, E naught cell is equal to E naught cathode minus E naught anode. E naught cathode is nothing but that of hydrogen because I have already given. This is cathode minus anode. So 0.0 volt of hydrogen minus of zinc, minus sign as it is as per the formula, and for zinc it is minus 0.76 volt. Minus of minus, naturally it will become positive, you will get plus 0.76 volt. So this is how you can calculate the potential of any half cells using hydrogen as a reference electron. Okay, so here we come to the end of the story. So I hope you would have understood the working of this particular Danieli cell. You have understood the working of this standard hydrogen electron and how to calculate the standard cell potential, because now we can use this particular standard cell potential formula to calculate the numericals which are there in the case of Nernst equation. Wherever we have Nernst equation, there we will have this E degree cell. So our concept has to be very clear. What is E degree cell? E degree cell, that is E naught cell, and the normal cell potential is different. This is under standard conditions. These are under always standard conditions. Standard condition, again I repeat, 298 Kelvin, that is 25 degrees Celsius, 1 molar concentration. Clear? So this is the topic that we are covering today. This is a short video because I don't advise you to go for a longer video. Whatever. Thank you for the patience. Okay. You got any queries, you can just get in touch with me. Okay. So this is part of our online session. Okay. So I can be of some help to the student fraternity here. Okay. Okay.